Hey everybody, this is the 2014 free response question number 3. So in this problem, we're given the graph of f. The function f is defined on the closed interval from -5 to 4, consists of 3 line segments that's shown in the figure. Let g be defined as g of x equals the integral from -3 to x of f of t dt. So we can see from right here then that g is this accumulation function, all right? And that's going to be important as we work through these problems then. So part A asks us to find g of 3. Well, we're given an equation for g of x. So if I want to find g of 3, I'm just going to take out x and put in 3. So g of 3 is going to be the integral from -3 to 3 of f of t dt. And we know that an integral just means find the area under the curve. So we're looking from -3, which is right here, to +3, which is right here. So we're looking at this triangle that's above the x-axis, so that'll be a positive area. And then we're looking at this triangle, which is below the x-axis. So the triangle that's above, triangle is 1/2 base height. So 1/2, the base is going from -3 to 2, which is 5. And the height of the triangle is 0, 1, 2, 3, 4. Okay, and then we need to look at this triangle that's underneath the x-axis, which means we need to figure out what this point is. We know that the x value is 3, but we need to find the y value. Well, this point right here is the point 2, 0. And then we know that this one is the point 4, -4. So we know then that this must be at -2. So we can use slope to kind of think about it. We went down 4 and over 2. So if I'm going to go only over 1, I'm going to end up going down 2. So that negative triangle then, so it's going to be a -1/2. The base is 1 and the height is 2. So overall, we end up getting, let's see, this is 10 minus 1. So we get that g of 3 is equal to 9. Part B asks about the open interval between -5 to 4, where the graph is increasing and concave down, the graph of g. Well, for g to be increasing, we know that that means g prime has to be greater than or equal to 0. And for the graph of g to be concave down, we know that g double prime needs to be less than 0. But we have to think about what we were given in this specific problem. Well, we were given this accumulation function. So if g of x is equal to the integral from -3 to x of f of t dt, we need to actually find g prime and g double prime so that we can then use them. So g prime is going to require us to use that fundamental theorem of calculus. So we're going to take the derivative of this integral, which hopefully you guys are okay with doing. Remember, you plug in the upper bound. So we're going to do f of x times the derivative of that bound, which is 1. And then minus, plug in the lower bound, times the derivative of the lower bound, which in this case is 0. So we get that g prime of x is actually equal to just f of x. And so that's going to be important as we kind of look through some of this stuff that we do. Okay. And then to find g double prime, we're going to take the derivative of that, so we end up getting f prime of x. So what that tells us then is that g prime is really just f, which is the graph that we were given. G double prime is f prime, which means we're going to be looking at slopes. So if we think back to what this question is asking us, we're looking for where g prime is greater than or equal to 0. Well, what that really means is g prime, we know, is equal to f. So we're looking, where is f greater than or equal to 0? And then for g double prime, we know that g double prime is equal to f prime, which is the slope of f. So we're going to be looking for, where is the slope of f less than 0. So if we look at our graph, we're looking for f is above the x-axis and decreasing. So let's think about what that might be. I'm going to get rid of all these marks that are on here. So here we are above the x-axis and we have a negative slope. And here we are above the x-axis and have a negative slope. So we're going to write about those two intervals. So let's see, -5 to -3 and 0 to 2. So g is increasing and concave down. On the intervals, let's see, what do we say? -5 to -3 and 0 to 2 because, and this is where you have to be careful with your justifications. So normally we would just say g prime is positive, right? But we weren't given g prime, so we have to make sure that we relate it back to the function we were given. So g prime, which is f, is positive, and g double prime, which really means we're looking at the slope of f, is negative on these intervals. I forgot to talk about points on here, so I'm going to do that really quickly for you guys. So part A here was worth 1 point. So it was really just, did you get your answer? And then part B here was worth 2 points. So it was 1 point for getting the intervals, and it was 1 point for giving your reason for why you picked the intervals that you picked. Okay, part C here gives us this different function. So now we're looking at the function h of x, which is equal to g of x over 5x, and we're asked to find h prime of 3. Well, we can't find h prime of 3 without first finding h prime of x. So that means we have to take the derivative of this function. And hopefully you can look at that and recognize that we're going to need the quotient rule. So we're going to do low d high, so 5x times g prime of x, minus high d low, so g of x times 5, all over 5x squared, right? Low squared goes down below. So if we think about what that means, let's see. That's going to be 5x times g prime of x minus 5 times g of x all over, this becomes 25x squared. Okay, so let's see. Now we want h prime of 3. So that's going to be 15 times g prime of 3 minus 5 times g of 3 all over 25 times 9. So let's see, g prime of 3, we're going to have to think about what that means. Well, we set up at the top that when we found g prime of x, that was really equal to f of x. So if I want g prime of 3, that means I need the function value at 3, which we had actually already found before. We found it to be -2. So this is going to be 15 times -2 minus 5 times, we need g of 3. Well, g of 3, I think we found in part A. Yeah, g of 3 is 9. All over, let's see, what does that become? 225. right? 25 times 9. So let's see, h prime of 3 is equal to negative 30 minus 45 is going to get us negative 75 over 225. So we really get h prime of 3. If we want to simplify it down, we'd get negative 1/3. And of course, you don't have to simplify it down. AP would take really anything from this step forward. They would give you the point for the answer. You don't have to simplify it down. Speaking of points then, this one was worth 3 points. So it was 2 points for correctly finding h prime of x. So could you take the derivative and use the quotient rule appropriately? And then the last point was actually for the answer. So if you could get to where this star is, then you would get the point for the answer. And then if you simplified it down correctly, you'd still get that point. If you make an error in your simplifying, though, then you would lose the point. So be careful there, or since you guys will be taking the AP exam at home, you can use your calculator. All right, for part D, it says the function p is defined as p of x equals f of x squared minus x. Find the slope of the tangent line where x equals negative 1. So we know slope of the tangent line means the derivative, which means we're going to be looking for what is p prime of negative 1. Well, in order to find that, we have to first find p prime of x. So p prime of x equals, we can see there's a function and a function here. So we're going to take the derivative of the outside, right? We need our chain rule. So f prime of x squared minus x, and then times the chain, which is going to be 2x minus 1. Now all we're going to do is plug in that negative 1. So p prime of negative 1 is going to equal f prime of negative 1 squared minus negative 1 times 2 times negative 1 minus 1. So we're really going to get f prime of, let's see, negative 1 squared is 1 plus 1 is 2. So we need f prime of 2 times, let's see, 2 times negative 1 minus 1, so times negative 3. So we need to find f prime of 2. Well, we were given the graph of f, which means if I want the f prime, right, I'm going to write it up here so we know what it is we're looking for. We're looking for f prime of, did I say negative 2? Positive 2. Which really just means we're looking for the slope at 2. So if I could find the slope of the line that this is on, I'd be good to go. And we actually found it earlier because we were finding it in order to get this point here. So we know the slope of that line is negative 2. So that means then that this is negative 2 times negative 3. So we get that p prime of negative 1 is actually equal to positive 6. And there's our answer. This part was worth 3 points. It was 2 points for correctly getting p prime of x. So did you remember that chain rule and stuff like that? And then it was 1 point for your actual answer. All right, thanks for watching, guys.